Yeah, very good. I should be recording it. Thank you, Tessa. Yeah, it's recording now. Okay. So, yeah, it's recording now. Thank you. So this is the first problem essentially, and what we're doing is showing the steps to solve for a linear equation. And so we're down to step one was just to distribute. Step two was to collect all the variables, but there's nothing to collect in this particular one. Step three is to make sure the variable is on one side, and you do that by, in this particular case, by adding 18 to both sides. Then you move on to step four. We want to make the coefficient of the variable 1. In other words, we're not solving for minus 6x, we're solving for x. So in this particular case, you have to divide by minus 6. You do it on both sides. So the left side, it factors out. So now you have x is equal to 42 divided by minus 6, which is minus 7. Okay. And then the last thing is you check to make sure the solution is correct. And you do that by inserting what you got x, or the variable equal to, into the original equation. In this case, it becomes 6 plus minus 7 plus 3, and you check to see whether that's equal to 24. And so it's minus 7 plus 3 is minus 4. Minus 4 times minus 6 is 24. 24 is equal to 24, therefore it checks. Okay, therefore minus 7 is the valid um, condition for this equation. Okay. Um, so these are the steps. You should know how to do this. Simplify each side of the equation as much as possible. Use the distributive property to remove any parentheses. Then collect all the terms, all the variable terms on one side of the equation. Then collect the constant terms on the other side of the equation. Make the coefficient of the variable equal to 1. That's either by dividing or multiplying by something. And then checking the solution. Okay, those are the steps you should follow. And the homework that's what you'll be doing in the homework, most of it. Okay. Okay, here's another one. We're just going to go through these. Okay. This one is solving minus y plus 9 is equal to 8, where y and 9 are in parentheses. So this negative sign on the outside impacts both of these, the variable as well as the constant. So you'd multiply that. This minus, it really means minus 1 times everything in parentheses. So it's minus 1 times y, which is equal to minus y. A minus 1 times plus 9 is equal to minus 9. So you've got minus 9, or minus y minus 9 is equal to 8. You get the variable on one side by moving the constant, and you're doing that by adding 9 to both sides. So the right-hand side becomes 17. The left is minus 1. This would show up as minus 1 times y. So you'd want to divide by minus 1. Or you could really multiply by minus 1 too. It wouldn't make any difference. It's the same thing. But on the left side, you'd end up with y. The right side, you're going to end up with a negative 17. That's the last step here. And then you go ahead and check it. You take this negative 17, you plug it right back into the original equation. You make sure the left side balances to the right side. If it does, you've checked it, and y is equal to minus 17 is the correct answer. Okay. Here's another one. 5 times a minus 3. So we're going to distribute first. We're going to multiply 5 times a and also 5 times minus 3. And we do this so then we can see all the terms and then we can collect them, right? So you definitely want to get rid of that bracket. That's the first thing you're going to do. And you do that through the distribution process. Combine the like terms. In this case, there's two constants. There's a minus 15 and a plus 5. That equals minus 10. So then you go ahead and you add 10 to both sides. So you get the variable on one side, right? So in this particular case, you've got 5a is equal to 0. Well, we don't want 5a, we want a. So divide both sides by 5. You can divide 5 into 0 and you still get 0. So a is equal to 0. Okay. You go ahead and check it. Take that 0, put it in for a, and see if it's true. Be 5 times negative 3, which is negative 15. 15 plus negative or excuse me, negative 15 plus 5 is negative 10. Negative 10 is equal to negative 10 on the right-hand side. Okay. And these are ones that you can try. We'll talk about that at the very end. Okay. Okay. Well, actually, why don't we do this? Let's pause here, and I'll have you guys both work on that first one. Okay. Look at 2 times m, because this lecture does go quick, and so we have time. So you've got 2 times m minus 4 plus 3 is equal to minus 1. So I'm going to stop sharing. So do you have that written down, both of you? Okay. So I'm going to stop sharing. I'm going to go to my board, my little whiteboard. I'm going to work with it. Okay. So here. Okay. So the problem was, I'll just put it right here. 2 times m minus 4 plus 3 is equal to minus 1, right? So what's the first thing we do?
So we would distribute.
We distribute, right? So when we distribute, what do we get?
2m and negative 8 plus 3 equals negative 1.
Okay. Equal to negative 1. Okay. So now what's the next thing we do? Ella, are you there?
Add like terms.
Okay, add like terms. So what are the like terms here?
Negative 8 and 3.
Okay, and what's that equal to? A negative 8 and 3 would be equal to what?
Negative 5.
Negative 5, right? So then that's equal to minus 1. So it looks like that. Okay, Tessa, what do we do next?
So now we would add 5 to both sides.
Right. And you can look at it like your original 1 and 2 step equations that you're probably familiar with doing. You look like this. Let's see here. Okay. Just a minute. Sorry. So it becomes a deal like this, right? So now you've got 2m is equal to 4 on the right-hand side, right? And what's the last step? What do we do?
So now we divide by 2 on both sides.
2 on both sides. So m is equal to 2. Okay. So now what's the last thing we do? What's step number 5? What do we do? Anybody?
So now you check. You plug in to where m was and check.
Right there, right? So now it becomes 2 times 2 minus 4 plus 3 is equal to 1. This pen doesn't work very well. So 2 minus 4 is minus 2. So it becomes minus 4 plus 3 is equal to minus 1, and you had minus 1 on the right-hand side, so therefore it checks, right? Because this is minus 1. And that's how you do it, right? They're all done like this. Some are just a little more complicated. There's more steps, there's more things to collect, but that's the process, okay? And we'll get a little further in here. We'll realize that this doesn't always check, okay? If it doesn't check, there's a couple of reasons for that, okay? And we'll get to that part. So I'm going to stop sharing that, and I'm going to go back to the to my original screen, right here. Okay. So here's another one with a fraction involved, but it's the same process. you're going to distribute the 2/3 times 6m minus 3. 2/3 times 6 is 4. 2/3 times minus 3 is 2. So then this is equal to 8 minus m. On this particular one, we've got a variable on both sides, right? So you're going to, you want to just have that variable on one side. So in this particular case, you're going to add m to both sides so that you have a positive variable here. You could have solved for the variable on the right-hand side, but it's more convenient to keep it positive. So that's why they would put that, they would add 1 to m, or add 1 m to both sides. They could have added negative 4m to both sides, right? To get rid of the variable on the left-hand side. But they chose to do it this way. So when you do that, then you get 4m plus m is equal to 5m minus 1 is equal to 8. Now you want to get the constant on the other side, and you do that by adding 2 to both sides. So 5m is equal to 10. Then you're going to divide both sides by 5 because the coefficient is 5 times the variable. And so you want 1 as a coefficient for the variable. So then m is equal to 2, okay? And you check it just like we did before. Put that 2 in for here, right there, and you just go ahead and check, and you realize that 6 is equal to 6, okay? Okay, here's another one. I'm starting getting a little messy, but they're not that bad. Again, you're going to distribute. You got 8 minus 2 times 3y, which is minus 6y, minus 2 times 5 is minus 10. That's equal to 0. Then you're going to combine like terms. In this case, it's the 8 and the minus 10. That's minus 2 on the left-hand side. Now, since you have both sides on the left, or both the constant and the variable on the left-hand side, you want to move that constant to the right-hand side. And you do that by adding 2 to both sides. So now you get minus 6y is equal to 2. Now you can divide by negative 6 on both sides so that this will factor out and you'll just have y. So y ends up being equal to negative 1/3. Okay. Then you go in and check it just like we did before. Okay. And you embed it there, you'll see that 0 is equal to 0 in this case. Okay. Okay, we'll get to the point where there's different conditions here. I don't know whether it's coming up next or not, but maybe it is. So now here's one where we'll have to distribute on both sides of the equation. So it's a little longer, right? So the equation is 4 times x minus 1 minus 2 is equal to 5 times 2x plus 3 plus 6. So we just distribute on the left side, so we get 4x minus 4 minus 2. Do it on the right side, we get 10x plus 15 plus 6. Now we collect the like terms. On the left side, we're going to collect that minus 6 and that negative, or that negative 4 and that negative 2 to make it negative 6. On the right-hand side, we're going to add plus 15 to plus 6 to get 21. So now you've got 4x minus 6 is equal to 10x minus 21. So you're going to subtract 4x again, so you'll have a positive variable on the right-hand side. So you subtract 4x from both sides. So it's 0 on this side, 0 minus 6. On the right-hand side, you've got 10x minus 4x plus 21, or 6x plus 21. So now you're going to go ahead and you'll just subtract 21 from both sides. Again, because you want this variable on the right-hand side to be by itself. And when you do that, you get negative 27 on the left-hand side is equal to 6x. And now you're going to solve for x. So you're going to divide both sides by 6. And you're going to get minus 9 over 2 is equal to x. Okay, so now you're going to go ahead and check it. So take this improper fraction and just embed it into the equation. Don't change it to a mixed number. Keep it like this so you can do some factoring. Okay. You understand what I'm saying there? This is equal to negative 4.5. But if you put negative 4.5 here, it gets clunky and it's harder to manage. So keep it like this. Keep it as an improper fraction. And when you do that, you can see you can do some factoring. This 4 times negative 9 over 2 minus 1. This negative 9 over 2 minus 1 is the same thing as negative 11 over 2. Now you can see you can factor. You can divide the 2 into the 4 to get 2. 2 times negative 11 is negative 22. It makes it easier to do it. Do the same thing on this one here. 2 times minus 9 over 2 plus 3. On this particular one, you can factor this 2 out right here. And that's what they've done. So it becomes minus 9 plus 3. And so it's minus 6 inside the brackets times 5 becomes negative 30 plus 6. Okay. So now you check. Minus 24 is the same thing as minus 30 plus 6, right? So it checks as minus 24 is equal to minus 24. Then you'd go back and you would put, well, we have put it in there to check it. Okay, another example. Here we've got brackets within brackets. Okay, so just follow the PEMDAS rules. Do the parentheses first. Do all the parentheses. Then you do the exponents. Then you do the multiplying, dividing, then adding, subtracting from left to right for both of those last two. Anyway, so it looks like this. This is what it looks like. Simplify from the innermost. So what we've done is we're distributing the 8 across the 2s and the minus 5. And that gives you minus 16s. Minus 8 times minus 5 is plus 40. And doing the same thing on this side, you're distributing. Yeah, they were finally distributing it down here. I don't know why they waited so long, but anyway, you're going to distribute that 15 across 40 and across minus 5s. Okay. You're going to consolidate the 3 and the 40, so you get 43. So now you distribute that 10 across 43 and minus 16, which gives you 430 minus 160s. The right-hand side, you're going to distribute the 15 across 40 and minus 5, 600 minus 75s. Now, in this particular case, yeah, we want to have a positive variable. So in this case, you're going to add 160s to both sides. So it'll go away on the left-hand side, and it'll just be 430 plus 0s. And that's equal to, on the right-hand side, it's going to be 600 minus 75s plus 160, because you added it to both sides. Plus 160 and minus 75s is 85s. So now you've got 430 is equal to 600 plus 85s. Okay, now you're going to subtract 600 from both sides because we want the variable to be by itself on the right-hand side. So we want to get rid of this 600, move it over to the left-hand side. We do that by adding a negative 600 to both sides. So we get 170 is equal to 85s. And 170, or excuse me, 85s, you divide both sides by 85. 85 goes into 170 two times. So s is equal to minus 2 because it was minus 170. Okay. And you do the same way in checking. Take that minus 2, embed it in for s, and just go through the math and make sure the left side equals the right side. And when you do, you'll get that 750 is equal to 750. Okay. So these are all conditional equations. They all have one condition, right, where it's equal to just one value. We're going to see some other kinds of equations here in a little bit. I'm not sure if it's this one or the next one. I can't remember. But here's another one where you've got a decimal form, 0.36 times 100n plus 5 is equal to 0.6 times, it was 0.36 on the left, 0.6 on the right. So it looks like that. The first thing you're going to do is distribute. That's what we've done here. 0.36 times 100 is 36. 0.36 times 5 is 1.8. And then you distribute on the right-hand side too. 0.6 times 30 is 18. 0.6 times 15 is 9. Okay. And now you're, again, you want to get the variable by itself on one side. In this case, since this is larger than this number, you're going to subtract 18n from both sides. 18n, 18n. So on the left-hand side, you've got 36n minus 18n, so it's going to be 18n plus 1.8. On the right-hand side, this is going to go away, and you're going to have plus 9. Okay? Now we're not done yet, because now we have to get this constant right here on the right-hand side, so we have the variable by itself. So we subtract 1.8 on both sides, and we'll get 18n is equal to 7.2. Now we divide by 18 because we want the coefficient of 1 multiplied by n. So it'd be 18n divided by 18 is equal to 7.2 divided by 18, or n is equal to 0.4. Same thing, put it back in here, embed it into the equation, make sure it checks out. And if it does, you know that this is a conditional value, okay? It's called a conditional equation, okay? Now we're going to get into the other kinds of equations. So we can classify equations as to conditional. That's what these are, because they have one solution, right? This equation only works if we use the condition where it's equal to, where the variable is equal to one value, okay? An equation that is true for one or more values of the variable and false for all other variables. I guess it could be plus or minus 1, or there may be cases where you might have more than one, but the point is it is just a specific number of values that it works in, okay? But now let's look at a different set of equations. What if you had one like this? 2y plus 6 is equal to 2 times y plus 3. Let's see when we solve for y. Well, first of all, you distribute. So you're going to have 2y plus 6 is equal to 2y plus 6. Well, now, if you take away 6 from both, or take away negative 2y from both sides, the y's go away. They're gone. All you're left with is 6 is equal to 6. Well, it's true, 6 is equal to 6, but this would mean that this would be an identity. You could put any value you wanted in the spectrum of all the way from negative infinity to positive infinity for y here, and this equation would be true, right? So that's why it's called an identity, okay? Any value you wanted to put in, didn't make any difference, okay? So that's an identity kind of equation. Here's another example. If you have 5z is equal to 5z minus 1. On this particular case, if you subtracted negative 5 from both sides, the z's go away, but now you've got a 0 on the left side and negative 1 on the right side, right? This is called a contradiction. It can't be true because 0 doesn't equal negative 1, right? So there's three kinds of equations we're looking at: contradictions, identities, and conditional equations. Okay. Part of this homework will be you'll have these equations to go through and evaluate and to tell me whether they're conditional, whether they're contradiction, or whether they're identity. And this will be on your quiz on Monday too, or on Tuesday too. So, um, so you know how to do it. Okay. Here's some more examples. Classify this equation, whether it's conditional, identity, or a contradiction equation, then state the solution. So here's the equation, okay? You've got 6 times 2n minus 1 plus 3 is equal to 2n minus 8 plus 5 times 2n plus 1. So the first thing we're going to do is distribute, just like we've done in all these others. So left side is going to be 6 times 2n, or 12n, and it's going to be 6 times minus 1, or minus 6, plus 3. On the right-hand side, you're going to have 2n minus 8, and you're going to distribute the 5 times 2n plus 1. That's going to be 10n plus 5. Now collect like terms. Left side, you've got 12n, and you've got a minus 6 and a plus 3, so that's a minus 3. So now you've got 12n minus 3. On the right side, you've got 12n also. And you've got minus 8 and plus 3 is minus 3. So this one, if you go ahead and take out or subtract negative 12n from both sides, the n's disappear, and you've got negative 3 is equal to negative 3. So this is called an identity because that n value could be anything. Whatever it is, that equation will still be balanced, right? It'll still be a real equation. So that's an identity type equation. Okay. So let's look at this one. We're going to try this, and I'm going to have you both work on it. Okay. And then I'll give you a few minutes. So write this down. Put 4 plus 9 times 3x minus 7 is equal to minus 42 minus 13 plus 23 times 3x minus 2. Okay, so I'm going to write that down and I'm going to go ahead and share. So you guys start working on that. Ella, are you listening?
Yep.
Okay, so start working on that. So it's 4n plus 9 times 3x minus 7 is equal to minus 42x minus 13 plus 23 times 3x minus 2. Okay, and I want you to solve it and tell me what kind of equation it is. So I'm going to stop sharing and I'm going to go to my board. Okay. So it's 4. Right? 4 times 9, that's 9 times 3. Let me see. Okay, 42, 52, 62, 27. How are you guys doing on it? Do we have it?
I'm done. Yeah.
Okay. Ella, how are you doing?
I'm done.
You're done. So what kind of equation is it? Either of you?
Identity.
Identity. Is that what you say too, Ella?
Yeah.
Okay, so if you looked at it, it would look like this, right? So the next thing you would do, you'd subtract 27x from both sides, and you'll get minus 59 is equal to minus 59. So it shows you that whatever value you put in here for x, it's going to satisfy that equation, right? So it's an identity. That makes sense? Okay, so I'm going to stop sharing and we'll go on. Okay. Share. Okay. Okay. Okay, here's another one. We'll just follow it. Classify this as a contradiction, identity, or conditional. 10 plus 4 times p minus 5. So the first thing we'll do is distribute. 10 plus 4p minus 20. Combine like terms. You've got the 10 and the negative 20. So it's 4p is equal to, or minus 10 is equal to 0. Now go ahead and move this to the right side by adding 10 to both sides. So now you've got 4p is equal to 10. Divide both sides by 4. So you got p is equal to 5 over 2 after you go ahead and factor, right? Reduce it to the lowest common denominator, or 5 over 2. So the equation is true, so it's conditional, right? And you'd prove it. You'd take this 5 over 2, plug it back in for p, and make sure the left equals the right, right? Okay. Okay, so why don't we do the top one there? Do the 11 times q plus 3 minus 5 is equal to 19. Okay. Q plus 3 minus 5 is equal to 19. Okay, so do you have that written down? Both of you? Ella?
Almost.
Okay. And Tessa, you got that? She dropped, I think. Darn it.
I do have that.
Oh, you do? Okay, good. I couldn't tell you were there or not. So I'll let you both finish it. I think I'll just write. Let me see, 11q plus 11 6. I'll let you tell me what it is. So do you both have that?
Almost.
Almost, okay. I
Or
mean,
I've got it all written down. I'm just working on the problem.
I'm with you, okay. I haven't even written it down, so I'm just one step behind you here. Minus 5 is equal to 19. So just a minute. So 11 times cubed plus 3. So if I stop sharing, you can go over here, go here, go here, go here, and go here. So it's 11 times q plus 3 is equal, or minus 5. Minus 5 is equal to 19. So plus q. Okay. Let's shoot this minute. My board doesn't. Oh, this thing's terrible. I'm sorry. Negative. So what did you guys get?
So I got that same thing.
Same thing.
That-
Okay.
Yeah, Q equals negative 9/11.
Over 11. Okay. So it's conditional, right? There's one answer, and if you took this answer and you went ahead and put it back in here, boom, it should satisfy the equation as long as we did our math right, right? Okay, stop sharing. Go back. Okay. Okay. So we just did this one. Okay, here's another one. We'll just go over it together. It's 5m times 3 times m plus 3 is equal to 2 times m, 7m minus 11. We have to distribute initially, so we get 5m plus 27 plus 9m is equal to 14m minus 22. Combine like terms. Left-hand side, you've got 5m and 9m, so it's 14m plus 27. And that's equal to 14m minus 22. Now go ahead and subtract, since you got 14m on both sides, we subtract 14m both sides. And now we end up with 27 on one side and negative 22 on the other side. And obviously they're not equal. So there's a contradiction here, right? So this equation contradicts. I mean, it doesn't have a solution, right? It has no solution. Okay. Contradiction. Okay. So here's the three kinds of equations: a conditional, true for one or more values of the variables and false for everything else, one or more values. Identity, true for any value of the variable. It's all real numbers, negative infinity all the way to positive infinity. Every number would work in this thing, right? As long as it's real, as long as it's not an imaginary number, it's going to work. And contradiction is the third type, where it's false for all values of the variable. There's no solution. So only one of these has no solutions. The other has all solutions, and the conditional has one or maybe one or two solutions. Okay, that's the distinction between those three. Okay, so now we've got the exercises. So let's take a 10-minute break, and then we'll get back and we'll talk about the homework, and we'll go over some of the problems and we'll go over them together, actually solving them for ones that aren't your homework problems, but other problems. Okay, so make your homework easier. So take a 10-minute break, or actually let's just go to 6 o'clock. It's 11 minutes. Okay, we'll get back together at 6 o'clock. Okay. Okay. I'm going to see if the other person ever responded to anything here. No, I don't have anything from her. Interesting. Okay.
But I don't want wasted paper.